I wanted to take this opportunity to basically give you an overview of where the landscape is evolving in terms of how LLMs and in general AI is being deployed. So that's the context of the talks, and basically if you move around and basically get into the depth of it, like how do you actually deploy AI, right? And I'm not meaning going into a chat and prompting. So that's the first of it, right? But if you are an enterprise or if you are a developer who is actually trying to do AI for yourself, you need to move beyond deploying well-known models for your application. See, that is the crux of my talk. And there are certain interesting challenges and problems with AI. So I'll also tell you how to address that, and also how do you deploy that while addressing those challenges, right? So typically, if you ask me a bouncer question, right, I'll say I don't know, right? Or if I'm trying to walk through an interview, I'll probably take a stab at it. So these are only two options. But there's an interesting problem with AI where if you don't do it or do AI the right way, there is a problem of what we call as hallucinations, right? Where AI is trying to guess something, AI is being imaginative and trying to, within its own limited data corpus, it's trying to imagine something which it is not, right? I'll give you an example. So let's take this, right? So in the context of AI, it is well understood in the context of NVIDIA what's the NGC image, right? Which is the NVIDIA catalog image. So if you ask a Llama 2 what's an NGC image, if you actually bother to read through the responses and all, it is actually trying to download something from NASA, some image that it considers as an NGC image, right? So this is what happens, like it will try and guess anything. Now, there's a simpler solution to that, which is prompting. This is the very, very first thing. So now you say the same thing, but you say that, okay, NGC GPC cloud, GPU cloud with E2E, blah, 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 blah. You prompt it. Now you are getting a much, much better contextual answer where it says like this is how you launch an NGC image, right? So this is the first thing. Now, second thing what happens is if the LLM does not have context about your own data, then also it's pretty useless, right? So I'll give you an example. So I also tried AI when it was getting started. So very first thing what I did is I looked at my support system, right, where we are answering customer queries and so on. And I thought like, okay, this is a good case to automate. So we could reduce the amount of manual interventions required and so on. So I integrated, started with ChatGPT and integrated on my help desk. So I tried answering a simple or tried to generate a response for a very simple question. So there was a customer ticket where he was asking us something about scaling Mongo and also some of the problems with Mongo, right? You know what OpenAI did? It gave me a very lengthy response saying that, okay, these are the documents you could try. End of the document, it said to the customer that if none of these work for you, please find an alternate provider. Right? So this is my help desk answering. So you could imagine where this is going, right? So unless you are fine-tuning it with your own data, or at least you have a live pipeline of data which you are ingesting and then giving it more context in terms of prompts, AI is going to be useless for you. AI is not like you say 10 times AI, you rub a bottle, a genie comes out, does everything, right? So AI is like where you actually have to do something. Right? So prompt engineering, RAG pipelines, fine tuning. Prompt engineering is the most easier part, right? You put any fancy, so there are like n number of courses online like where you can learn prompt engineering, but that's just the first step in AI. The second step is fine tuning, and then you go into a RAG pipeline. So this example is clear, like unless you are giving prompt, it's like completely useless. Now, the second part that what you can do is, like I mentioned, like you cannot even have a very large prompt. For example, if I have a very small request, I cannot send a 10 MB prompt, right? So it's very obvious that there are limitations at how much you can do prompt engineering, right? You could probably like add some more context, some more text, but nothing other than that. You could probably send some more context information like a country information or like some user demographic information, but that's about it. So you really need to do either fine tuning or RAG, right? Okay, so I'll just talk about a logical view of RAG, right? So what you do in a typical RAG pipeline is you ingest large amounts of data using pipelines, right? And then you chunk it and push them onto vector databases. Now, this vector database could be anything. It could be Quadrant, it could be Milvus, any of the commercial stuff or like open source stuff, it's all there. But you are getting that real-time data ingestion going on a day-to-day basis. It goes onto the vector DB. So to give you an example, so this is your LLM, the brain is your LLM, and it is trying to reference this. It's almost like an open book test with RAG pipeline, right? So where continuously you are being supplied with new books and you are gleaning over them and answering your LLM queries, right? Now let's talk about a simple RAG pipeline, right? So what happens is you have like this is the serving of the RAG pipeline. So what you do is like you first do the ingestion part, which is you either chunk your PDFs or your Google Docs or your emails. It could be anything, medical journals, Supreme Court judgments, like people are doing LLMs for legal domain, medical domain, all sorts of domains. So what they're essentially doing is they are crawling all these kinds of huge amounts of almost petabyte scale of data and then storing it onto a vector database. Now what happens is when you receive a query, you basically do a vector search for the most related parameter, right? Or the most related chunk of data which you think is useful, and then you prompt it to the LLM, right? So this is how most context is added. Now if you prompt it and then if you share it with the LLM, then the response is going to be not just contextual but also within the confines of your vector database, right?
Training phase, right?
This is during the inference phase, right? Training phase, see, you don't need training in RAG pipelines. That's the whole point. If you're doing fine tuning, then you need to fine tune or basically run through the training process with your custom data. But with RAG pipeline, what you're doing is every day, let's say, I'm talking about the medical domain or the legal domain, right? Every day new judgments are coming, every day new research papers are coming in. So you just crawl them on a daily basis and then keep getting ingested. So your LLMs are up to date. If you're doing fine tuning, it's not going to be up to date. It's only going to be up to date at a certain level, right? And this is a very hard problem. So there's a reason why OpenAI does not say that like my LLMs are updated every day, right? They cannot do that because the amount of data that they are crawling, it's just not possible to train all of them in a single day and keep you updated. So which is why for smaller models, like it's still an LLM, but a smaller size model, you could afford to do this where you are trying to build an academic LLM or a medical LLM. You could crawl the entire that domain data on a daily basis and keep it up to date. So this is one way of doing it. Right, so what is the vector database, right? So vector search is almost like a pin code search, right? So it's trying to get you the relevance of it. And interestingly, if you look at Milvus, they have also recently started supporting GPUs for even vector search. So you are having like a very huge speed for GPU for vector search, which is enabled by GPUs. So those help as well. And of course, you can use a Postgres with an extension for vector search, but the performance, it's not built for that, right? So go ahead and use any of the open source like Quadrant, Milvus. All of these have replication factors, striping abilities. So it scales out of the box. You don't have to be really doing something very, very fancy to scale this up. It's just a Helm chart. Just keep modifying the YAML values to scale the amount of resources that you are adding. It keeps on scaling, right? So it's as simple as that. So, and the key component is like once you have deployed this, you can use any open source models, or you can even use well-known and popular available pipelines which are there, right? So pipelines are again one of the key components of a RAG pipeline, standard pipeline. So this is nothing but your Argo workflow or your Kubeflow pipeline. So that basically determines like how often you run it, right? Whether you are scheduling it to run every 30 minutes or 1 hour or per day. You keep on ingesting those data that is available into a Quadrant or a Milvus. That's it, right? So then let's talk about fine tuning. So fine tuning is a RAG pipeline in a snapshot, right? So it's like you have, let's say, 0.5 petabyte of data. You take Llama 2 and or Llama 3, 70 billion or 3 billion, whatever is your use case. You fine tune it, the output is again a fine tuned model, right? So this is like this, right? You have a smaller brain and you put more context information, it becomes a bigger brain. So fine tune is a one-time activity, right? So you take a bunch of data, fine tune it, and then the model will answer based on the context that it has learned from the newer bunch of information. Whereas a RAG pipeline is a live information, right? Live, determined by the amount of data that you can actually ingest, right? So when we say a RAG pipeline, you are essentially deploying something which is live and you are adding more information to it on an almost real-time basis, right? So for example, if someone does a news LLM, they need to crawl every news website on an almost daily basis or an instantaneous basis to be able to help their users get more collated information from an LLM that is deployed specifically for news. Okay, right? So this is it, right? You're making a bigger brain. Whereas in the context of RAG, you're not making a bigger brain, but you're giving it enough books that it can study at any time, right? Bigger brain is like subjective. Right, now what do you do? Basically, like, there's a reason why there's always a trade-off between fine-tuning and RAG, because there are certain performance penalties for RAG pipeline, right? It's not, though that's the ideal way that people should be doing, but it's not from a performance standpoint and the resources required to run a RAG pipeline at scale. It's not always easy, right? So what people do is they do, it's almost like a database snapshot, right? You take a snapshot, but you also maintain the query logs, right? So people do fine tuning on a finite kind of an interval. Let's say every month they launch a new model, but then they supplant that model by a RAG pipeline for a limited set of data, right? Your RAG pipelines will die if I have like multi-year data. If I put on a RAG pipeline, I might not be able to scale that because there is resources required. You need to run very large search and index nodes to be able to implement your vector database as well, right? So it's a balance, right? So it's like, it also depends on which key use case you are covering. So I know of banks and financial contracts guys who have done this LLM, like where they have said up to 2020, all the contracts are there in my LLM. So please ask it, right? Similarly for legal, they have said like, okay, up to 2022, we have crawled every judgment and every reference material, please query it. So that is one way of doing it. But a lot of innovation is happening on RAG where they're saying like, my model can understand up to this cutoff date, but then the latest date or whatever is the latest information, that can be supplanted by RAG. But again, like I said, if you build too much into RAG, there's a performance penalty, and basically like we say that it's 1 to 5%, but if you're not optimized your infra, this can be much larger performance penalty if you're doing RAG. Like anyways, like data requirements vary. Anyways, it's all subjective of how much you're doing in RAG versus a normal stuff. And the last part, right? So let's say that you have trained your data, you have also fine-tuned your model and with whatever custom data that you have, and you have also supplanted additional knowledge to the model by using a RAG pipeline. Now the other part, the interesting part that comes in is there's a lot of regulation that is happening the world over for AI, right? I think everyone is following the EU Act, and I think India is also going along the same way. I think it's just a matter of the current cycle of the elections to be over before we have like real impetus from the government agencies on how to regulate AI and so on, right? So like what you need to do is like you need to put what is called as a guardrail, right? There are well-known open source tools available today, NVIDIA guardrails AI and so on. And what they actually do is they moderate content which can be violative of certain geographies, certain personalities, certain policies and all of that, right? So you don't need to avoid them. So for example, like one way of avoiding it is like if you ask an AI model like which is the best country in the world, right? So it's like for everyone their own, right? So instead of saying like, I don't know, that's the standard guardrail response, that I'm not qualified to answer this, right? But then you can also build nuanced responses to this, like, look, this is a subjective thing and so on, right? So it's a very tricky world. Lot of legal efforts of various, even large AI companies are being spent on safety and trust and explainability of models. It's a very evolving field. So simple guardrails are like where you are saying that I don't want to leak out any sensitive information, and there are guardrails around. For example, if I'm doing an enterprise LLM, every user, they have their own privileges and access, right? If I train on petabytes of data, and if a document that belongs to the CEO cannot be accessed by the most junior most guy, this is like very simple multi-tenancy guardrail. So there are many facets of guardrail, apart from the politics part or the harassment part, like guarding those, that's one facet of it. But there are other guardrails in terms of user management, in terms of ensuring that there's no hallucination. All of that can be controlled using a guardrail. So guardrail is nothing but a template which can basically like add more context as a prompt, and it can be guiding the LLMs into avoiding certain pitfalls in terms of loaded responses, right? So NVIDIA guardrails, if you look at it, they also provide certain sample policies, but it's mostly like an API-driven framework. So you could innovate and say that, okay, these are my 1,000 rules that I want to do for my medical LLM, right? So somebody says like, so for example, like suicide prevention, right? For a lot of logical medical cases, they are really worried about it. So if you ask an AI that I have cancer stage 4, this, that, and so on, it might actually recommend you euthanasia, right? For all we know, that's the very logical step, like if you look at it in binary terms, right? But that's not how human beings operate. So a lot of such work is being done in terms of fine-tuning, safety and trust, and RAG pipelines, ever-evolving field. But this is how we think it's going to happen, right? So basically, like LLM responses are coming in. So this LLM could be a single LLM, or it could also be your RAG pipeline, fine-tuned RAG pipeline, and you put guardrails, and then you ensure that your responses are like very, very moderated and useful. Thank you.